Welcome to this video lecture on the subject Optical and Microwave Engineering. So in this lecture we are going to discuss about reflex klystron. So reflex klystron is a type of vacuum tube used in electronics for generating and amplifying the microwave signal. So it is a microwave oscillator. So it is used in the range of 1 GHz to 40 GHz. It operates based on the principle of velocity modulation of an electron beam which is passed through the resonant cavity. So here the name of the reflex klystron comes from the fact that portion of the energy from the output signal it is reflected back into the tube. So which is used to modulate the electron beam, resulting in higher efficiency and improved performance. So these are used in various applications like microwave ovens, radar systems, communication systems and particle accelerators. And some characteristics of klystron are resonant cavity, where a klystron consists of resonant cavity made up of two cylindrical cavities. So these are separated by a small gap called a drift space. And the electron beam is used to produce a narrow high velocity electron beam produced by electron gun. It is directed towards the resonant cavity. The electrons are focused by magnetic field and are made to pass through the drift space. And next is bunching. As the electrons pass through drift space, they are affected by alternating electric field produced by the resonant cavity. So this causes the electrons to bunch together, forming groups or bunches. Next is the amplification. The bunches of electrons that pass through the resonant cavity interact with the electric field, so the field can be amplified. The amplified field then interacts with the next bunch of electrons, resulting in further amplification. And also oscillation. The interaction between the electron beam and the resonant cavity can cause the cavity to oscillate at a frequency determined by the dimensions of the cavity. So this produces the microwave signal that can be used for various applications such as radar and communication systems. Working principle of reflex klystron. So it involves the interaction of electron beam with the resonant cavity to generate and amplify microwave signal. So here we consist of an reflex klystron where resonant cavity used and repeller is used for repel the electron beams. The electron beam is produced by an electron gun and directed towards the resonant cavity, and bunching occurs in the drift space. So the velocity modulated electrons are bunched together and lose their kinetic energy when they encounter a positive peak of a RF field. So the power delivered by the electrons is equal to the power loss in the cavity where microwave oscillation is started. So the interaction between the electron beam and the cavity can cause oscillations at the determined frequency. So which is given by the dimensions of the cavity. A portion of the energy from the output signal is reflected back into the tube to modulate the electron beam. So this results in higher efficiency. And interaction with the resonant cavity. When the bunches of electrons pass through resonant cavity, they interact with alternating electric field, which results in increase in velocity of electrons. And advantages are high frequency stability, where reflex klystron operate at high frequency with excellent stability, which makes them useful in applications for precise and stable signals. And it generates high power microwave signals suitable for applications which require high power output such as radar and communication systems. And it has a small size compared to microwave tubes, which makes them ideal for applications where space is limited. And also it provides low noise levels, which makes them suitable for high signal to noise ratio such as communication systems. And also it has a long lifespan. And some disadvantages are high voltage requirement and limited frequency range, limited power control because it typically operated at fixed power output, and sensitivity to temperature changes. So because it is affected by changes in temperature, which can limit their stability and reliability in some applications. And complexity, they are complex devices which can make them difficult to design and manufacture. And applications are radar receivers, local oscillator in microwave receivers, portable microwave links, and pump oscillator in parametric amplifiers. And some of the performance characteristics are they are used in frequency up to 2 to 200 gigahertz and power output as 10 milliwatt to 2.5 watts. You see the assessment questions. The klystron tube used in klystron amplifier belongs to the linear beam tubes, and which is a single cavity klystron tube that operates as an oscillator by using a reflector electrode after the cavity. So the answer is reflex klystron. Thank you for listening this lecture.